Hello everyone, this is Mrs. Pagan, and in today's lesson we'll be talking about piecewise functions. We'll kind of start evaluating these functions in the couple earlier problems, and then at the end we'll learn how to graph them, and we'll do one here in this video and one in class. Alright, let's kind of start evaluating. So it says evaluate the function for the given values, and they give us two functions. Let f of x equals negative 3x plus 2 and g of x equals x squared minus x to the third. So we have our two functions. Well, in example number 1 it says can you evaluate f of 2? So obviously we're going to have to use the f function because it wouldn't make sense to use g. So we're going to go ahead and put the f function, and f of x equals negative 3x plus 2. And since they want us to evaluate f of 2, we're going to replace the x with 2. So here's an x, replace it with 2. And here's another x, replace it with 2 plus 2. Notice I put parentheses every time I do that. So then I have f of 2 equals negative 3 times 2 is negative 6 plus 2. And then we have f of 2 equals negative 4. Alright, so that's how we evaluate a function, and I'll kind of jump to g of 0, and I'm going this way now. We have a g of 0, so we're going to have to use the g function. So I like to first write the function, and then what I do is substitute in the value for x. So x is 0. So we have g of 0 equals 0 in parentheses squared minus 0 in parentheses cubed. And we get g of 0 equals 0 times 0 is 0 minus 0 times 0 times 0 is 0. So g of 0 equals 0. So that's how we evaluate functions. What I'd like for you to do right now is pause me. And I want you to try number 2 yourself and number 3 yourself. And I'm 100% sure you can do this. Did you pause me? Pause me. Alright, we're going to go over those problems in class, so make sure you pause me and solve them. Alright, let's go into our first goal. So our first goal is to make sure, and let me erase that. Our first goal is to make sure that we evaluate these functions. And what you'll see is instead of 2 or 1 function, we actually have 2 functions. So let's quickly look at what's given to us. Alright, so evaluate each function. Okay, let's look over here. It says evaluate each function given the values. So we're going to go ahead and solve example 1 together. And what it says is f of x equals 5x minus 1 if the x value is less than negative 2. And f of x equals x minus 9 if the x value is greater than or equal to negative 2. So first we have to figure out where does the x value lie. So looking at f of negative 5, we know that x, I'll write it above, equals negative 5. Well, the question is negative 5 less than negative 2? Or is negative 5 greater than or equal to negative 2? One of these statements should be true. Well, we know that negative 5 is less than negative 2. And because we know that, we would have to use this first function. So we know that f of x equals 5x minus 1. Well, we know that f of negative 5 equals 5, negative 5 minus 1. We replace the x's with negative 5. And we know that 5 times negative 5 is negative 25 minus 1, which equals negative 26. So our final answer is f of negative 5 equals negative 26. And I'm going to box that. Alright. Now, I am going to erase some of these things that we did here just to make sure that I don't get it confused with the second equation. And here in the second one it says f of 5. Well, in this case x is 5. So x equals 5. And what I want to know is 5 less than negative 2? No, that's not true. Well, is 5 greater than or equal to negative 2? Yes. So we're going to go ahead and use x minus 9 as our function. So f of x equals x minus 9. Well, we're looking for f of 5. And since 5 is x, we're going to replace it, minus 9. 5 minus 9 is negative 4. Therefore, our final answer is f of 5 equals negative 4. Notice that we do not touch f of 5 at all. It's a notation. Alright, so let's go ahead and look at f of negative 2 and figure out which function would I use. So I'm going to erase all of this again for my last problem. And let's start. Let's do this one in red. Well, we know here that x equals negative 2. So let's ask ourselves, is negative 2 less than negative 2? No, never. Is negative 2 greater than or equal to negative 2? Well, it's not greater, but it is equal to. Since it says greater or equal to, we know x minus 9 is our function. So we have f of x equals x minus 9. But x is negative 2, so we're going to go ahead and replace that. I like to put parentheses, minus 9. So f of negative 2 equals negative 2 minus 9 is negative 11. And here is our final answer. Well done. Alright. Now, I'm going to go ahead and kind of just look at this one, but we're going to do this one in class. So if you want to, you can go ahead and try this. But if you're not comfortable with it, we will be working on this in class. Alright, let's go ahead and graph some of these. We're going to do one example of graphing, and then we'll do one in class as well. So the first one says, let's graph the following piecewise function. And the reason it's piecewise is because there's two pieces. 1, 2. Alright, so what we do is I like to make two tables because there is two functions. I'm going to put my x's and y's here. And I know that y equals x plus 6 for the first one. And then I look at my restriction and it says x is less than or equal to negative 3. So the first thing is, since negative 3 is here, we always put it here. And we ask ourselves, if it's less than or equal to, would that be open or closed circle? Well, since it's equal to, we say it is a closed circle, kind of like what we did on the number lines. Then we find numbers less than negative 3. Well, we have a negative 4 and a negative 5. And then we substitute into our function. So what we're looking at is the following. Oops, sorry, wrong place. We put it in here. I'll do the work on the side. Negative 3 plus 6. Well, that's 3. How about when it's negative 4 plus 6? I'm putting it in here, guys. 2. How about when it's negative 5 plus 6? Well, it's 1. So now we have 3 points that we can plot to figure out where our graph goes. We start with the first one and then go in that direction. We do not look back. So we're going to go to negative 3, 1, 2, 3, 4. I'm sorry, negative 3 and up 3. So here's our closed circle. Then we go to negative 4 and 2. We just put a little dot. Negative 5 and 1. We put a little dot. And we go connect the dots, and we keep going in that direction. Since it's all the values less than, that's the direction we go. Notice that we did not go to the right side at all because we always start with the first point and we don't look back. Alright, let's go ahead and do the second one, and we'll use blue on that one. And what we're going to do is the same process. We're going to just kind of create a table of x's and y's. Here's an x, here's a y. In this case, y equals negative 2/3 x minus 3. Alright, so then we pick our values. We always start with what we see here, which happens to be negative 3 as well. Then we ask ourselves, x is greater than negative 3. What are numbers greater than negative 3? Well, I know 0 is 1. I'm just now jumping around. I like positives better. And I know 1 is 1 as well. So we'll kind of get those answers. Alright. When x is negative 3, we're going to just go ahead and substitute it in here and figure out what we end up getting. And I'm going to solve these actually underneath. For the first one, it would be negative 2/3 times negative 3 minus 3. Alright, well, once I have that, I'm going to evaluate. I know 3 on top, 3 on the bottom cancel. Negatives create a positive 2 minus 3, so that equals negative 1. Alright, let's go ahead and do the same thing. I need some space, so I'm actually going to erase this. Let's go ahead and do the same thing with 0. Well, what about if x was 0? Negative 2/3 times 0 minus 3. Anything times 0 is cancels to 0, and we're left with just negative 3. Alright, let's go ahead and do the last one. And the last one says we have 1. So negative 2/3 times 1 minus 3. Well, that's negative 2/3 minus 3. So we can actually say it's negative 3 and 2/3, which is approximately negative 3.6. Alright, now that we have that, we can go ahead and approximate these values. We always start with the first one, and I think we forgot something, and that's the open or enclosed circle. Well, let's see. If it's greater than, that means that it's an open circle because it's not equal to. So at that location, we'll have an open circle. Negative 3 and down 1, open circle. And from there, we're going to go ahead and move in the other direction. I'm actually going to change my color to blue. 0, 3. 0, down 3. Here's one of the points. I like to put them small. And then 1 and 2.6 negative, of course. So we're right there. So if I start with the open circle, go to the next point, then go to the next point, then keep going, then I will get my piecewise function. And that's what that looks like. Alright, we are going to be going over the last problem in class as well. So this one is in class. Thank you so much for hanging in tight. It is not an easy concept. That's why we'll be practicing more in class. But don't forget, before you're going to be showing me example number 2 and 3 for full completion of your notes. Have a great day, and I'll see you in class.